All right, more graphing the rationals. This is going on page 59 when we're done. All right, so we're going to get some other unique looking graphs in here today. And so we're going to start here by factoring like we do on all the rest. So in the numerator, I can factor out an x squared. That leaves me with x plus 2. In the denominator, I already have the x minus 3 factored out, and then I need to factor the rest. That's going to be x plus 6 times x minus 3. All right, so do I have any point discontinuity? Anything I can cancel out? No. But can I rewrite this a little bit better? Yes, because I have two of these. So this becomes x squared times x plus 2 over x minus 3 squared times x plus 6. Okay, so there is none for this. I get the roots from the numerator. Got two of those. That's -2 and 0. I have two vertical asymptotes, which would be x equals 3 and x equals -6. Do I have any tangency or togetherness? Togetherness. And? Do I have tangency? I have tangency too. Remember, x is a factor, so I have this squared up here. Now, an x squared like this doesn't tell me anything, right? Because that's not a factor. This one is a factor. So I've got that in the numerator and denominator. So does the numerator give me tangency or togetherness? Tangency. So I have tangency at x equals 0, and I have togetherness at x equals 3, right? Is this top heavy, bottom heavy, or tied in degree? It's tied in degree, because I can clearly see the x cubed up here. Down here it's x squared and x, which is x cubed, so y equals 1. This is none. What's my y-intercept? 0, 0. Good. If you have an x-intercept that's at 0, 0, your y-intercept is at 0, 0. Okay. Everybody with me so far? Okay, so we are going to rewrite the factored form down here. Got f of x is equal to x squared times x plus 2 over x minus 3 squared times x plus 6. All right, so I have 4 things that go on here. See, my smallest will be -6, then -2, then 0, then 3. So -6 is an asymptote. That's an open circle. -2 is closed. 0 is closed. And 3 is open. Okay, we agree with all that? All right, so we're going to substitute stuff in. I'm going to substitute in a -7. Whatever I put in here gets squared and it's positive. -7 plus 2 is going to be negative. Whatever I put in here gets squared and it's positive. And then -7 plus 6 is negative. So that is positive overall. Here I can substitute in a -3. First term in the numerator is positive no matter what. Then negative, then positive, then positive. So that's negative overall. Then I can substitute in a -1. So that's going to be positive, 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 positive. That's positive overall. Then I can substitute in a +1, and that's going to give me positive, 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 positive. That's positive overall. Then 4 will give me positive, 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 positive. That's positive overall. So this is what my sign chart looks like. So let's talk about whether or not that makes sense and where it didn't alternate, because a lot of the ones we've done have alternated, but sometimes they don't. So let's look at when they don't. I know that I have asymptotes here and here, right? That's where I got some asymptotes. And here, on either side of the asymptote, it alternates, and here it doesn't. Why is that? What do I have here that I don't have here? Togetherness. This is where my togetherness happens, right? And that's what's happening with the togetherness, right? So if I have togetherness, it doesn't alternate. If I have togetherness, it doesn't alternate. If I don't have togetherness, then it does, because that's the idea of that. All right, so then here, if my function's positive, then it's going to stay positive. You can't see that. If it's positive, then it's going to stay positive and look like that, because what's happening at 0? A bounce, your tangency, right? And so here, I've got tangency, it doesn't alternate. Here, I've got togetherness, it doesn't alternate. So we have a shortcut on our sign charts. Now, it's important that you know how to actually do them. That's why I had you do them for so long. But if we do this first one, we know it's going to alternate positive and negative because we don't have togetherness here and we pass through the axis. That happens unless there's tangency or togetherness. So we can easily just do the first one and then fill the rest of it out if we have an understanding of what's going on. Okay? If that confuses you once we start doing that, then you can just go back to doing all the signs, and that's fine too. There's nothing wrong with that. Okay? All right, so let's get our asymptotes on here. I have one at -6. And I have one at 3. Bless you. And then I have a horizontal asymptote at y = 1. All right, so since I have a horizontal asymptote and it's not at y = 0, I have to check to see if my function intersects the asymptote, and if so, where. In order to do that, I need the function that's multiplied together, which means that if I'd actually canceled anything, I'd have to multiply this back together, but I didn't cancel anything. So it would be nice to start with this one, but that's not fully multiplied out either, right? So I'm going to have to multiply the denominator. So I'm going to move this over here. My numerator is still x cubed plus 2x squared. Then I've got to multiply these two together, so I'm going to distribute that x first. That gives me x cubed plus 3x squared minus 18x. Then I distribute the -3, and I get -3x squared minus 9x plus 54. And then I clean up the denominator. I get x cubed plus 2x squared all over, so I only have one x cubed term, so x cubed. Then I have 3x squared and -3x squared, those zero out. I have -18x and -9x, that's -27x, and then plus 54. So this is the y equals that I'm going to use down there to test that. Why? Because algebra. You got to know how to multiply your functions together. I don't have time to reteach that. Okay, so let's rewrite that down here. And I get y equals x cubed plus 2x squared over x cubed minus 27x plus 54. And then my horizontal asymptote was at y = 1. So just like on all the rest, I take whatever this is, substitute it in for y here, so I get 1 equals x cubed plus 2x squared over x cubed minus 27x plus 54. I distribute or multiply both sides by the denominator, so I get x cubed minus 27x plus 54. Okay, keep writing that down. Okay, so that equals x cubed plus 2x squared. All right, so then I can subtract x cubed from both sides. That leaves me with -27x plus 54 equals 2x squared. That is a quadratic, so I need to set it equal to 0 to be able to do anything with it. I want to keep this positive, so I'm going to move everything to the right. So I get 0 equals 2x squared plus 27x minus 54. Okay, so good news and bad news. The good news, or the bad news is it doesn't factor, so we would have to use quadratic formula here. But the good news is I'm just going to tell you what the answer is because I'm not going to give you one to work on your own that's this crazy. It just ends up like this because I was trying to force this graph to do certain things. So I'll just, you just got to know how to solve it. And then when you do, we're not going to spend time doing it. You get negative 15 and about 1.8. Good enough for this graph. So that tells me that my function intersects my asymptote how many times? Twice. Okay. So let's look at our graph then. My function is going to intersect this asymptote at negative 15. Well, negative 15 is way off my graph, so I know it happens, but I can't even graph it. About 1.8 I can put on there, so about 1.8 is like right there. So that's somewhere it's going to cross. Let's put the rest of the points on here that we know. We have a root at negative 2 and one at 0. And then that's all we got because my y-intercept is at 0, 0. So looking at my sign chart, from negative infinity to negative 6, from negative infinity to negative 6, my function is positive. So not only is it positive, but I know that it's positive and it intersects the asymptote, but way out here, so not where I can actually see that. So I need to find at least one point because I don't have any. Let me see if I can fit some of that work in here. Bless you. So that's at negative 6. We're going to start with f of negative 7. So if I substitute negative 7 into here, negative 7 squared is 49 times negative 7 plus 2 is negative 5 over negative 7 minus 3 is negative 10 squared is 100. Negative 7 plus 6 is negative 1 times negative 1. All right, so I know that 5 goes into 100 20 times, and this is negative over negative, so I get 49 over 20. So 20 goes into 49 twice with 9 left over, so it's about 2.5, right? Good enough to graph on here. So I can go to negative 7 and then 1, 2.5. Do you think that 1 point's enough? Yeah? I think it's enough. I don't think we need anything else. All right. Any questions about how we got any of that? We're good? Okay. So then let's look at the middle part of this graph. From negative 6 to negative 2, it's negative. So I know it's going to have to come up like this. From negative 2 to 0, it's positive. So it's positive, but I know it doesn't go like this because I can't cross my asymptote there. So it's positive right here. I have tangency here, so it's going to bounce. And then it's going to stay positive. It's going to intersect my asymptote right there and then keep going. Then from 3 to infinity, it's positive. So it's going to have to come like this, and it does not cross the asymptote again, so I know it'll have to look something like that. So I don't know, I don't think I need any other points in here, because again, this is going to come up like this. It's going to intersect, right? It's where it intersects the axis. It's positive for a little while, then it bounces, and then it becomes positive again, something like that. It's the only thing that could happen if you understand your sign chart and your tangency and all that kind of stuff. Okay. Any questions at all? All right, so I know what this is supposed to look like, but I don't have any points, so I need to find some, at least one. I can start with 4. So I can do f of 4. Let's see. If I do f of 4, where's my graph? 4 squared is 16 times 4 plus 2 is 6. And then 4 minus 3 is 1 squared is 1 times 4 plus 6 is 10. I can reduce before I multiply. 16 and 10 I can both divide by 5. So that's going to give me 48 over 5. Is that right? Wait, what? No? Oh, I said it wrong, but I did it right? Okay, I'm sorry, thank you. I was like, wait, what? Okay, I have no idea what just came out of my mouth, but thank you. I divide them both by 2 is what I like to say. I get 5 here and I get 8 here. Guess my brain got ahead of me. Okay. 48 over 5. Thank you. That is right. Okay. So 5 goes into 48 9 times with 3 left over, so it's about 9.5, right? It's 9 3/5, but to graph it on here, I can go to 9.5. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Do you think I need another point? I think I need another point. Unfortunately, and none of these numbers are coming out pretty, right? So f of 5. Let's see what happens here. See if I can say it right, too. So 5 squared is 25 times 5 plus 2 is 7 over 5 minus 3 is 2 squared is 4 times 5 plus 6 is 11. Okay. So I want to multiply this together. If you have 7 quarters, how much money do you have? 7 quarters. $1.75, right? So 7 times 25 is 175 over 44. And that's a really ugly number, right? That's disgusting. It's not just ugly, it's disgusting is what I heard. Okay, so because I'm not asking you what is f of 5, if you had to give me what is f of 5, boom, that's your answer, right? But we need to graph this thing. And it's okay to estimate because our boxes are so small. That's why with 3/5 and 1/2 is fine on here. So what if I change 44 to 45? That'd make it a little easier to work with, right? Sure. So I can divide them both by 5 now. This gives me 9 down here. 5 goes into 17 3 times with 2 left over, so I get 35 over 9, which is way better, right? And that 35 is almost 36. What's 36 divided by 9? 4. Do you think 4 is a pretty good estimate for this? Like, good enough? I think so, too. Okay. Sure. 1, 2, 3, 4. You're not allowed to play with numbers and estimate if you're actually asked what is f of 4. We're trying to find a good estimate on the graph for it. It's fine, okay? You can kind of manipulate things a little bit. Again, this one, all kinds of nasty things happened because I was trying to force the graph to do some things, and I knew that was going to happen, but I also knew I was going to work through it with you. So the ones you have shouldn't be so disgusting. Like I heard. What questions you got? We good? Do you understand how the puzzle works to put it together? We're getting these down? Okie dokie. All right, so when you flip your paper over, your next number is 7, I think, because like I said, the numbering is all messed up. So I'm going to find 7 on here, and we'll just do that one next so y'all can keep up with what's going on there. Okay? So go to number 7, because it should make sense on yours to go next. All right, so we're going to factor. When we factor, what's the first thing we should always look for? GCF, yes. So I'm going to factor out of 3. That leaves me with x squared plus 3x minus 4. And then the denominator would be x plus 2 times x plus 2. And then I can continue my factoring, and this would give me x plus 4 times x minus 1 over x plus 2 squared. Everybody with me so far? Do I have any holes? No. Any zeros? Yes. I want -4 and at 1. How many vertical asymptotes do I have? 1 at x equals -2. Right? Do I have any tangency or togetherness? Yes, I have togetherness. Okay. So, and that is that x equals -2. Top heavy, bottom heavy, or tied in degree? Tied in degree. It's easier to look at this one. I mean, you can look at any of them, but this one's a little bit easier. Y equals 3. So this is none. My y-intercept is at 0, what? -3. You got it. All right. Everybody okay with where everything came from? All right, so I'm going to scroll and we're going to rewrite our factored function here. So f of x is equal to, I don't have the right we're on number 7. Right? Okay. 3 times x plus 4 times x minus 1 over x plus 2 squared. Okay. All right, so then I want to do my sign chart. I have 3 things to put on here. It's going to be at -4, -2, and 1. Bless you. This is closed, open, closed. Okay, so let's try our little shortcut to the sign chart. You got to do the first one, so we're going to do -5. That 3 does nothing. -5 minus 4 is negative, and then positive, so this is positive overall. So I should alternate everywhere unless I have tangency or togetherness. On this particular one, I only have what? Togetherness, and it's where? -2. It's here at this asymptote, right? Which means if this is positive, this is negative. I do not alternate here because I have the togetherness, and then this is, ooh. And then this is positive. You see how that works? And again, if that gets confusing to you, you can always just go back to doing all the signs. Whatever works for you is fine. So we get positive, negative, negative, positive. All right. Put our asymptotes on here. We have an asymptote at -2. And we have a horizontal asymptote at 3. So since our horizontal asymptote is not at 0, we have to check it. So we'll go back up here and see what we got. Oh, I don't need to go back up there. We've got we don't have to redo anything here. So my original was 3x squared plus 9x minus 12 over x squared plus 4x plus 4, and then my horizontal is at y equals 3. So just like on the rest, I take whatever this is, I substitute it in for y, so I get 3 equals 3x squared plus 9x minus 12 over x squared plus 4x plus 4. Okay. Then just like all the rest, multiply both sides by the denominator, so I get 3 times x squared plus 4x plus 4 equals 3x squared plus 9x minus 12. Then I'm going to distribute this 3, so I get 3x squared plus 12x plus 12 equals 3x squared plus 9x minus 12. Okay, so I've got 3x squared and 3x squared. If I subtract 3x squared from both sides, those zero out. I have a 12x over here and a 9x over here, so I'm going to subtract 9x from both sides, so that'll leave me with 3x. That leaves me with a positive 12 and a negative 12, so I'm going to subtract 12 from both sides, and that's going to give me a negative 24. So x equals negative 8. Where did I lose you? I heard a what? Is it the 12s? Because you want to zero them out? That doesn't work. I had 12 over here. I subtract it to the other side. That's where I get my negative 24. So x equals negative 8, which means we do intersect the asymptote, and it's at negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right there, we're intersecting the asymptote. Then let's get the rest of this stuff on here. I have roots at negative 4 and at 1 and a y-intercept at negative 3. Okay. So think through the sign chart and what we have here and see if you can get an idea of what it looks like. If you're feeling confident, you can go ahead and draw it in. But I'll give you a second to think about it, and then I will talk you through it. Okay, so let's talk about the sign chart. From negative infinity to negative 4, it's positive. So from negative infinity to negative 4, it's positive. So I know it's above the x-axis, and I know I crossed the asymptote here, but remember, this doesn't go off to infinity like this. I have an asymptote. It's still, even if it comes up over here, it's got to come back down and be hugging the asymptote like that. And then this has to hug this asymptote. So it'll look something like this. Okay, hang on, I take that back. I gotta do it the other way. Even though the function's happening from left to right, I gotta get it. Something like that. But not really as straight as that looks. I couldn't get a good curve on it, but I want to get out of the way. All right. So then from negative 2 to 1, it's negative, so that should make sense right here, right? And then from 1 to infinity, it's positive, but it has to stay under the asymptote, right? Because I know that it doesn't intersect. So it's going to look something like this. What questions you got? We good? All right. Do what? Jot this down? Go ahead, yeah, go ahead. What's the next number you have? 6? Okay, because I know they're all out of order. It kind of does, and it has kind of the same, but the parent functions are symmetric. So, and this one's not, so, yeah. Well, it's not really supposed to be straight right there, but it does like go, the parent functions definitely don't intersect, so, but it does look similar to one of them. Okay, are we good? All right, let's go to number 6. Oh, hang on, I gotta find number 6. There we go. Mine are out of order too, but not in the same out of order that yours are. Okay, so let's factor this numerator. This is going to end up giving me 2x and x, and this would have to be 3 and 3, positive and negative, and that's old school factoring without grouping, just knowing what it is. And then, can I factor the denominator? No, I can't, right? This is not going to factor to anything. So it's just x squared plus 3. Can't factor that denominator. All right. Do I have any point discontinuity? No, I do not. My roots come from the numerator, so I do have negative 3 and a positive 3 halves. Do I have any vertical asymptotes? No, your vertical asymptotes come from the zeros of the denominator. So here's what happens if we set the denominator equal to 0. X squared plus 3 equals 0. So x squared equals a negative 3. So x equals plus or minus I times the square root of 3. Is that anything I can graph on my graph? No. And you don't necessarily have to go through all this, but I wanted to show you why it happens in case you're wondering why you can't. I mean, you can look at that and know you'd get something negative, and it's fine. You don't have to do the work. But so I have none. This is the first one of these where we have not had any vertical asymptotes. Do I have any tangency or togetherness? The answer is no, and you might feel like this one's a little tricky. I know I have an x squared here, but I also have an x squared here. Like, these aren't factors, right? These are the factors, and I do not have a factor that has an exponent on it. So this is a none. Is this top heavy, bottom heavy, or tied in degree? Tied, so this is y equals 2. Right? And then y-intercept is going to be at 0, what? Negative 3. All right, so let's do our sign chart. Scroll and rewrite. Let me find the one I'm supposed to be looking at for our number 6. Okay. So f of x is equal to 2x minus 3 times x plus 3 over x squared plus 3. Okay. So I only have 2 things that go on here because I don't have any asymptotes, right? So I have -3 and I have 3 halves. So the -3, actually both of them are closed circles because they're both zeros. So when I look at putting in -4, -4 times 2 is -8, that stays negative there. -4 plus 3 is negative. -4 squared is positive plus 3 is positive, so this is positive overall. Do I have any tangency or togetherness? No, I do not. So if this is positive, this is negative, this is positive. So I'm going to go a lot faster. All right, so let's get our asymptotes on here. I don't have any vertical ones. I just have this. So that's all I have. Look at your sign chart. Look at that. Think about what you might think it might look like. It's got to be positive, then negative, then positive, right? But we still have to check to see if it intersects the asymptote. So my original unfactored function is 2x squared plus 3x minus 9 over x squared plus 3. And my horizontal asymptote is at y equals 2. So I substitute 2 in here. 2 equals 2x squared plus 3x minus 9 over x squared plus 3. Then I'm going to multiply both sides, so I get 2 times x squared plus 3 equals 2x squared plus 3x minus 9. So that's 2x squared plus 6 is 2x squared plus 3x minus 9. So I can subtract 2x squared from both sides. I only have x on one side, so I'm going to leave it. Then I'm going to add 9 to both sides. So get 15 over here. X equals 5. So it does intersect the asymptote when x equals 5. Okay, so 1, 2, 3, 4, 5. We have that intersection point right there. All right, so let's put the rest of what we have on there. We have a root at -3 and a root at 3 halves, which is 1.5, and then a y-intercept at 0, -3. Everybody good with that? Okay.
Good morning, Maverick. That was your tone to please take attendance at this time. Teachers, please take attendance for 88 at this time.
Okay. So from -∞ to -3, it's positive. It's positive, and it has to stay underneath because I know it doesn't intersect over here. Then from -3 to 3 halves, it's negative. So it comes down here, hits my y-intercept, stays negative. Then from 3 halves to infinity, it's positive, comes up like this. Remember, it doesn't shoot off to infinity. Even though it comes up and it can go over, it's got to come back down. We don't know how high it goes up, but it goes up some, and then it's going to have to come back down. Okay? Make sense? So no vertical asymptotes here. Looks just like this. Okay, that's that first section of it. And it's going to come down here like so, something like that. I want to make sure you had one that no vertical asymptotes at all. The majority of the ones that we deal with do have them, but they don't have to. Any questions at all? Okay. The last number is what? 8, which is what the last number is supposed to be. But let's see if I can find 8. Oh, my 8's over here. There we go. Okay. So let's factor. This first one's going to be x minus 4 times x plus 3 times x minus 1. Can I factor the x squared plus 2? No. So I get x squared plus 2 times x minus 2 And that's the best I can do there. Any point of discontinuity? No. How many roots do I have? 3. So I've got -3, 1, and 4. How many vertical asymptotes do I have? 1. And it's at x equals 2. Do I have any tangent CR togetherness? No. Top heavy, bottom heavy, or tied in degree? Tied in degree, because it's going to be x cubed over x cubed, right? And so that's going to be y equals 1. This is none here. Y-intercept. So I 0 out all those x's. So it's going to give me 12 divided by -4, -3. Why would it be a -3? Is that what you said? Oh, we're always, yeah, you're right. I know. It's weird how that happens, right? Okay. So then, let's see, let me find number 8 here. We have f of x equals x minus 4 times x plus 3 times x minus 1 over x squared plus 2 times x minus 2. All right, so I have 3 zeros and an asymptote I have to put on here. So start at -3, and then 1, 2, and 4. So the 2 is the open circle for the asymptote. The other ones are closed. So I'm going to start with -4. -4 would give me negative, 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 positive, negative. That is positive overall. Do I have any tangent CR togetherness anywhere? Nope. So it's just going to straight up alternate. Okay. If you don't understand when it does and when it doesn't, maybe you should do the sign chart, like actually do the whole thing. Just depends on your level of understanding, I guess. All right. So then we're going to put our asymptotes on here. I make sure I'm looking at the right one. I have a vertical asymptote at x equals 2. And I have a horizontal asymptote at y equals 1. Then we're going to have to check and see if it intersects. But we're going to stop here for today. We're going to pick this up tomorrow. So we're going to do the same thing that we did before. We graphed a bunch today. We'll have to finish it up tomorrow, but then you'll have time to work on the rest. I'm going to go ahead and give you the assignment, though, so that you have it in case you're not here tomorrow, because that's what we will be doing.